Hi there, welcome back to the channel, and welcome to the first video in this Back to Basics series. The Back to Basics is really a series that I want to do using this particular radio, where I'm going to try and explain every single step of the procedure, a lot of the theory that goes into trying to understand really what goes into the workings of the radio, why we do certain things, what we should look out for, what we should be careful about, and really trying to pass on a lot of the information that I've gained over these past few years. I learned from a lot of really good YouTubers, mostly YouTubers. A lot of it was from printed media, but I'm a little impatient. I like to learn. I like to see people do things and use that as a learning medium. So I learned from a lot of YouTubers, and as I mentioned before, a lot of them just assumed that you knew stuff. And I want to go back a little bit because I've started doing that as well. I want to go back and try and explain a lot of the detail that I just glance over when I'm doing a normal restoration. Hopefully, this series will serve as a good basis for other people to build up their knowledge on restoring tube radios. In this particular case, it's a German set. A lot of the radios I do are German sets, but this applies to just about any tube radio from sort of 50s and 60s era. And hopefully that information will serve you well. If this sort of thing interests you, stick around, enjoy the video, enjoy the series. I still remember the first time I looked at a tube radio that I was planning to restore. And I've got to tell you, for me, it was quite intimidating for the simple reason that I knew two things about this. One was all the technology here was way before my time. And the other thing was it worked with very high voltages, which means that it could be dangerous. And that's where I'm going to start. These things have high voltages. I'm sure you know that, and I'm sure you also know that high voltages can be pretty uncomfortable if you touch them. So if you're getting into this sort of thing, as a lot of people say, you're doing so at your own risk. But anyway, I looked at this tube radio and I had to sort of figure out what was what. In other words, I had no idea of the anatomy of a tube radio. What are the sections? What are the blocks that make up this design and make this thing work? Obviously, some things are pretty easy to identify. You know there are tubes. At the beginning, you may not even know what they do, what the different stages are for. You know, what is that guy doing there? Why is that one different? Why is that one tall? At some point, you would have had no idea, like me. Now, obviously, a little bit of logic comes into play, and you start figuring things out. But I had to go to a lot of sources to try and get an idea of how this thing was put together, and therefore how I would be able to then restore it. And this particular one is actually a little bit more modern than the one I started with. This one's got a PC board. Now these boards came out in the late 50s, early 60s. This is a 58, 59 radio, and it's got a PC board. Now, the one I started on was completely point-to-point. It makes no difference, really. It really does not change the concept of how this thing was put together. If you understand the anatomy of the radio, if you understand the sections that put it together, that make up that radio, it doesn't matter whether it's on a PC board, whether it's on solder tags, whether it's point-to-point, it really doesn't make any difference. The idea is that you understand how this thing's made up so you can follow through every stage of the circuit and work out why it's working or not working. Now, if you're a beginner and you want to start restoring one of these, you have to have a service manual, schematic and service manual. Really, if you're starting off, forget about trying to do this by instinct or by luck. Get yourself a model. They can be very cheap to get these things not working. Find one that you have the instructions for. And in this case, I do. This is the full service manual for a series of models that includes the one that I'm working on. Let's see, we've got this is the Nordmende 59. It's also the 615. I believe it's also the Phono Super 59, the Caruso, the Cosima, the Parsifal, Rigoletto, and Traviata. And you will see that some things are specific to the various models. Now, this one is the Rigoletto 59 3D. You see, they actually give different instructions for different models up here. This is the schematic. This is the most important part. I mean, there is more stuff. This goes into how the transformers are wound for different areas, at different voltages. It gives you the alignment instructions. But at the beginning, you're not interested in this. This is the part that is most important. And it's important that you have a good quality schematic. Some of these schematics are very faded, very difficult to read. Get a good quality schematic. Remember, if you're starting off on this, you do not want to be guessing. If you make a mistake with a little transistor set because you put a 100 ohm resistor instead of 100K resistor, you might have a little poof and a little bit of smoke. With voltages like we have here, this can blow your tubes. It can actually blow up your output transformer. These things are very difficult to get. Here's the output transformer, by the way. It's replaceable, but you don't want to be handling that when you're starting off. So this is the Bible for our whole restoration series. Now, when you look at this, it's almost as intimidating as looking at the radio itself. Even if you do know how to read schematics, this thing is intimidating as hell. So what I do normally is I take this thing and I put it into a drawing program. And I'm going to go into an extreme of how you can break this down to make this whole thing more understandable. Let me show you what I'm talking about. You see, this is what you're looking at. I've imported this PDF into a drawing program. This is actually called Photo P. It's a free version of Photoshop and it's fantastic, right? I'll show you what you can do with this. When you look at the schematic, it's just too busy. So what we can do is actually make it simpler. And I've done this in various stages to show you what I'm talking about. The first thing I do is let's get rid of all the unnecessary stuff, the clutter. Let's get rid of some of these bits of information that we really do not need in order for us to understand the schematic. And first thing I'll do is get rid of that, okay? All this is a layer. I paint over that and I activate the layer. And there we go. We've got this thing simplified. It's becoming easier to read. It's still not easy to read. So we can take it one step further. What else don't we need? Well, we don't need to know what model it is. We don't need to know some of the tube socket pinouts. We don't need to know some of the values that we have on the top right. So let's make it even simpler and get rid of that. Brilliant. Now it's starting to look more like a schematic and less like a Pizza Hut menu. So if we take this one step further and get rid of stuff we don't need here, we don't need the switching at the moment. We've got the switches here. This is the actual schematic of how the switches work. Let's hide that. And now look what we've got. Now we've got the schematic in a format that allows us to really understand or try to understand what the signal path is here. We've got two signal paths. We've got actually three signal paths. FM comes in there. AM comes in there, the phono comes in there, and then we've got an output, speakers. That's what this is all about. You're bringing in audio into the power section, the audio section, which is then producing audio through your speakers. That's what the radio is doing. Now, whether the audio comes from your phono over here, whether it comes from FM as a result of the FM doing its business with the FM antenna over here, or whether it comes from the AM, meaning long wave, short wave, and medium wave. I think this is what this has got from here. It doesn't matter. The point is the audio, the resulting audio comes through, gets amplified, and comes out of your speakers. And then to drive all that, you've got the heart of the system, which is the power supply down here. Now we've actually got a little bit more than we bargained for on this power supply, but I'll get into that in a second. Now, the first thing is we need to sort of figure out what's what here. What are we looking at? Which sections do what? And I'll show you what I mean. If you look at this thing in stages and you do this, what is this? Well, this is the AM front end that takes your audio from your antenna, rather takes your signal from your antenna, and it does its business to tune it in order to allow you to obtain the signal or decode that signal coming in from your station, from the antenna, to ultimately come out as audio at your speaker. So if you look at this section here, if your AM front end, and when I say AM, I mean it works for long wave, short wave, and medium wave. If I isolate that, it's not so intimidating anymore, is it? And let's take it one step further. If we want to know what follows, we've got the mixer oscillator section. We'll go into how these two work together, but the point is that this purple schematic section is separated, is different from the green one. The green one brings your audio or your signal, I keep saying audio, brings your signal from the antenna. Let's say you've got a signal at 1 megahertz, 1000 kilohertz. Your signal comes in here. It goes to this point over here. Now, what happens next is you've got to tune it. You've got to pre-select it. This whole path is bringing in your entire AM band, everything your antenna can pick up. And you don't want that. You want that station that's at 1 megahertz, okay? So what you need to do is to pre-select it, wipe out or eliminate or dull the rest of the band, and you just want to focus on that signal. And this is where selecting between, say, long wave and medium wave broadcast band comes in. This is a circuit, this is a tank circuit that allows you to pre-select what you want to hear. And it's selected, it's tuned by this capacitor here. This is half of the tuning condenser, the tuning capacitor that is used to tune your AM. Now, when you do a tuning over here, and we'll go into more detail later, but when you tune over here, you're basically focusing on that 1 megahertz, that 1000 kilohertz signal. And what it's going to do is it's going to take that signal and it's going to pass it through to your mixer oscillator tube here. You see this this green line? That takes it through to there. The reason you've got a switch here is that the FM signal from this part over here is also going into that tube. So you choose to listen to AM. This is what you're doing here, right? So your signal goes in there at 1000 kilohertz. Okay. Then, what is this purple section? Well, this is called the mixer oscillator. It's a dual purpose circuit. And what it does is it takes the signal that you've tuned there. Remember, you've tuned that there. That also tunes that condenser, that half of the tuning condenser, because they are ganged, they are stuck together. And when you align to 1 megahertz over here, what actually happens is you're making this oscillator circuit align or tune to 1460. So 460 kilohertz above that one. And that is your local oscillator frequency, which then is going to mix with that one. So you're going to take 1 megahertz that you've pre-selected over here with that part of the can, and you're going to take 1.46 megahertz that you've pre-selected on the tuning on the oscillator. Those signals are going to mix inside this tube, and again you've got switches here to determine whether you're tuning to long wave or medium wave or short wave, because this oscillator will tune to 460 kilohertz above whatever you've pre-selected up here, right? So when you're looking at medium wave broadcast band, if you choose 1 megahertz, you're going to get 1.46 megahertz being produced by this local oscillator, this oscillator circuit, which is using a part of the tube. It's using that section of the tube. But what's happening is now you're pumping in 1000 kilohertz, and you're pumping in or producing 1460 kilohertz. And this is a mixer oscillator. What it does is it mixes the two, and the result of that mix is you're going to get 460 kilohertz. You're going to get a whole lot of other mixed frequencies. You're going to get the sum, the difference, the original plus twice the difference. Forget about that. All you're interested in is that this thing does a mixing, and it's going to produce the difference between what your local oscillator is producing and what your front end is tuned to, which means that at the output of this, you are going to get your intermediate frequency, which is 460 kilohertz in this case. It could be different for other radios, but it's 460 kilohertz in this case. It's coming out here and it's going on forward into the circuit. That is your IF frequency, and that is the whole principle of this type of receiver, that it mixes down to an intermediate frequency that is then manageable, detectable, tunable, you name it, okay? So we've looked at the two sections of the radio, the front end, that are related to the AM bands. But we've got another one. Of course we do. We've also got the FM front end. Now the FM front end is different. The FM front end has got an RF amplifier that amplifies the signal coming from the antenna over here, amplifies that signal. It then does a pre-selection over here. This is your pre-selection of the RF, and then it's got the oscillator mixer, the same as that thing's doing. It's got that over here where you tune. There, you see that tuning condenser? That's one part, that's the other part. You are then tuning to the local oscillator frequency. You're also tuning the local oscillator frequency to give you, again, another intermediate frequency. In this case, the intermediate frequency is 10.7 megahertz. So if I want to listen to a station here at 100 megahertz, right, I tune it, and I'm using that half of the tuning condenser inside the FM block, and I'll show you in a second what that is. I tune it to 100 megahertz. At the same time, I'm aligning or tuning this one and tuning that tank circuit, which is the oscillator, and that is producing 110.7 megahertz. And when they mix, again, I get a difference, plus the sums and all that, but I get a difference of 10.7, which then goes to here. So at this point, you see where that switch comes in. I switch between AM and FM. And with FM, it's interesting. The FM actually goes into that mixer oscillator. It just gets amplified. It doesn't get mixed with anything anymore because it's already done its mixing, and it's at a different frequency level altogether. Remember, you're talking about low end over here, 460 kilohertz. You're talking about 10.7 megahertz coming from here. So that goes in there, gets amplified, and gets pumped through to the intermediate frequency stages over here. So we can see that these three sections are actually completely separate or discernible. They are separatable, if you can say that. You can separate them to make them easier to understand. Now, this purple section over here is actually quite interesting because it's actually pretty easy to see. It's actually that box over there. You see, that's the tube, the ECC85, that does the two functions. One is the RF amplifier at the front and then the mix oscillator. And it's inside this box, this metal box. And the reason it's inside here is so that it basically eliminates noise from affecting the signal because you are working with higher frequencies over here. Okay, so this is the entire FM front end that is shown inside this dashed dotted line over here. You see, that's why they show it as a dashed dotted line. It's UKW Bolstein. I presume that's what enclosure. I'm not even sure what that means, but it tells us that this whole section is like a block that is separate. And now we've got these two or three sections looked at, we can go further. We've still got quite a bit of the radio that we haven't looked at in detail. And when we look at it, if you go one step further and you do this, this shows you the entire audio section, all the way from the end, which is the speakers over here. This is the output transformer that'll produce the audio, induce the audio into the speakers, into the low frequency section of the speakers. There's that section over there, which seems to come from high voltages. This is a high voltage point. Remember, this is the audio, the power tube. It's a high voltage point, but it is sending signal to these guys over here, which are the electrostatic tweeters. Some radios don't have them. The first one I worked on didn't have it, but you got to understand this thing's got high voltages on here as well. So again, be careful. So that is your speaker system. Part of this is not on this radio. You see these dashed lines. These are sort of external speakers, and it has to do with the fact that this schematic was also used for a cabinet that had turntable. And I know that because the power supply down here has got a turntable, a phono section, which also worked on this. So we ignore that for now. But this is the entire audio section, and it might look complicated, but it really is not. All this is a power stage over here. This tube is the power tube, which is inducing the signal through the output transformer, which then goes to the speakers. And I will go into a lot of detail in the future as we get to these sections. But this is the preamp stage, which takes the audio that comes from the front through these stages over here, comes through there, gets to there, and at this point over here, right, this switch will switch between whether we're going to listen to or pre-amplify and amplify the signal coming from the phono socket, from the FM block over there, or from the AM section over here. So that's where you're selecting between one or the other. In fact, it's over there, right? Radio or phono. Over here is another switch that determines whether you're listening to AM or FM. But we're going to go back there in a second. This is how this audio section works. We've also got a little circuit on the side here. This is the magic eye that tells us how close we are in our tuning. I'm painting it in because I'm trying to show you just how easy it is to be able to ignore parts of this mishmash of lines. You can actually, if you can isolate it, and you've got a problem in a particular section, or you're working in a particular section, you can sort of isolate a lot of this stuff and not worry about it. It doesn't have to scare you. And believe me, it sort of intimidated me in the beginning as well. Then we go one step further and we've got the IF amplifier. Now, the IF amplifier takes this signal, the intermediate frequency that this thing has produced, okay? It takes it into this section here, and you've got two IF transformers. This is one inside that dashed line. That's one IF transformer, and it's got two transformers in there. Now, this is quite interesting because this allows you to select the IF frequency to allow it to go through. You want that 460 kilohertz that's got your radio station music on it to go through. You also want, if you're listening to FM, the 100 megahertz signal to go through, or rather the station that you tune to at 100 megahertz, you want that to go through, but in fact what you're allowing through is the IF frequency that's being produced here at 10.7 megahertz. So this thing has got to allow through two frequencies, 460 and 10.7. Now, interestingly enough, they're in series. They're actually in series. And they're not, in some cases, one is actually shorted out. In some radios, they don't even short it out. And the reason is the 10.7 megahertz on a tuned circuit like this has no effect on the 460 kilohertz transformer, and the 460 has no effect, was not affected by the 10.7 megahertz transformer. That is not strictly true. There's a slight effect, but it's so small that most of the time you don't even short them out like they've done here. And this allows the 10.7 megahertz or the 460 to go through to this tube over here, which is the EF89 IF amplifier. Now, the IF amplifier takes those signals, those two, the 10.7 or 460, depending on whether you've selected FM or AM, and it amplifies it and sends it to another couple of IF transformers. This is another CAN that you see, surrounded by these dashed lines. And this then is where a trick happens, which is the detection of the AM signal from that 460 kilohertz, or the detection of or decoding of the FM signal from the 10.7. And that is another stage which I've called the detector stage, okay? This section over here. That's basically it. The result of this stage, it's one tube that has a lot of functions on here. You can see that. This is a diode. This thing here, this is a cathode and anode of one diode. Same cathode, anode of another diode. Here's another diode with a separate cathode. And then there's a cathode which is linked to these two cathodes, and it's got a triode. So this thing is used as the AM detector, diode. It's used as the FM and the ratio detector to detect the FM audio. And it's also used as part of the preamplifier. You can see that the brown circuit, or green, is the preamplifier. That triode is used to preamplify the audio, whether the audio is coming from the phono signal, from the FM, or from the AM, depending on what's being detected, what's going through the switching that we've selected over here. So that really shows you the components of the radio. Now, there's one major section missing, and to me, this is the most important part, and that is the power supply. Without the power supply, you can forget it. Nothing else will work. There's nothing you can do without power, okay? So I've drawn this in last, but you'll understand why in a minute. This is what I look at first. When I'm doing restorations, this is what I look at first. If this is not working, you're wasting your time. So the idea is you do this sort of backwards. But let me show you some of the sections on here that I've talked about, and then I'll come back and tell you how I attack these different sections individually. Now, the way this radio is laid out, it's very specific to the model. Every model, or just about every model, can be different. And it does not mean that they work differently. It just means that the way they've laid them out could be different. So when we look at the radio as it's laid out here, it does not mean that we can expect to follow those sections that we've seen on the screen in the same order. It just doesn't work that way some of the times. But generally, it's very easy to identify the sections once you understand what you're looking for. And here's the first section. We've got this thing over here. That's a tuning condenser. That's turning. You can see that, right? That is the tuning condenser for the AM. It's a big capacitor here. It's an air capacitor. It's got two sections, as I've mentioned. One is for the tuning the front end, and the other one is for the oscillator. So that's the capacitor there. This is part of the AM front end. It's the coils that you see on the schematic there. This is the ferrite core antenna. It's used for AM, mainly for long wave and shortwave and medium wave and broadcast band. Not so much for shortwave, or not for shortwave at all. We've got the FM block, as I mentioned here. And again, there's a tuning condenser, which you can see over here. That's also to tune your front end of the FM and the oscillator. So we're basically looking at the front end of the AM and the FM over here. And so far, we've only come across one tube, which is the ECC85. That's the FM front end tube. Then we take it one step further, and this is where we come across the ECH81. In this particular case, it's ECH81. These tubes can be different. They can use different models, different tubes to do the same thing. These German radios, the layout I have here, or the tube selection they have here is pretty standard. It does vary, but most of the radios I've done use an ECC85 for the FM and an ECH81 for the AM mixer oscillator. This is the first IF transformer that we saw there. And as you can see, there are tuning lugs for the primary and secondary of the FM and primary and secondary of the AM. I'm not sure exactly which is which at this stage, but the instructions will tell you. 2 of these will be for the FM, 2 of these will be for the AM. So at this point, at this tube, you're either working with 460 kilohertz for the AM bands or 10.7 megahertz for the FM bands. And that's what's going to go through to this guy over here. This is the EF89. Again, this can be a different tube, but in this particular case, it's pretty standard. This is the IF amplifier tube over here. And that takes a signal, those one of the 2 IF frequencies, and sends it to this IF transformer pack over here, which has that special function in that one section is, or the primaries are related to tuning for the best pass through of those IF frequencies. And the secondary side has to do now with the detection of whether it's an AM audio signal or an FM audio signal, which then goes through the switching that I've mentioned, having been detected by the diodes inside this tube. And this one is a EABC80, again, a very typical, this is a triple diode triode, if I'm not mistaken, very typically used in this function over here, but it also acts as a preamplifier for the audio that results from that whole mishmash that we've looked at, which then gets fed to the, what is that, the EL84 power tube, very standard tube as well. So this is the one that produces the power. This is then passed through the output transformer, which then goes off to your speakers. Okay, so that's the basic anatomy of the signal. We've also got over here the filter capacitors. This is actually a multi-can. I think this has got 2. Yes, this has got 2 capacitors in one. This is part of the power supply. And again, the power supply, to me, as I mentioned, is probably one of the most important sections. It's certainly the first section we're going to work on. And that involves a few stages, including the filtering of the rectified voltage that then is going to feed the various stages of the radio. But we can also, in this case, look underneath. Whatever you select over there, what you're selecting is actually the primary winding of this power transformer that's going to be activated, that's going to be powered, right? So depending on your main supply, it'll feed it to the correct primary winding, because your secondary winding should be always the same voltage regardless of what your primary is, or rather regardless of what your mains is. Let's say the radio needs 220 volts. It's got to get 220 volts regardless of whether you're on a 120 main system or 220 main system or whatever. The point is your 220 volts or 230 volts, in this case I think it's about 220. I can't read that there, but it's usually about 220 that comes out of these AC. That is the source of all the power that goes to your radio. It also has another winding, which is 6.3 volts AC, which is your heater winding. And again, we saw that in the schematic. That is used for all the heaters of the tubes, as well as the dial lamps and so on. So that is also produced by this power transformer. That heater winding is not rectified. It's used as AC. Now, the 240 volts or 220 volts, let's call it 220 for now. 220 volts AC secondary has got to be rectified, because at this point it's just AC voltage. So that 220 volts AC that's being produced then comes to this guy. And this guy is selenium rectifier, which is just a bridge rectifier. It's 4 diodes effectively that produces your rectified DC. It's very choppy when it comes out, but it's all DC. It then goes from there to there. Where is it? To there, which is the filter capacitor that I showed you on the top side. This thing's got a can with 2 filter capacitors in it. One of them is 100 microfarads, the other one's 50. That's rather unusual. Usually it's more like two of them at 47 or 50. This thing's got a big one at the front and a smaller one afterwards. But that's just used for filtering your B+, your main supply, your main positive supply. And that is what's going to serve again as the source for all your positive voltages in the radio. Now that obviously is a very simplistic look at the anatomy of this tube radio, but believe me, the look is simplistic because the system is quite simplistic. This is not complicated. It's intimidating if you've never done it before, but once you start eliminating the doubts, the confusion, once you start cleaning things up and start looking at something one piece at a time, it actually starts making a lot of sense. And it's a hell of a lot easier to work that way than when you're looking at a bunch of wires. And believe me, this one is not a big bunch of wires. This one's actually quite neatly laid out because it's got a PC board. But a lot of the radios that I work on don't have a PC board, so every little connection is another wire, or there's a component acting as a link. So looking at something like this is just begging for a more simplistic breakdown. And that is what I always try to do when I try to explain how these things work, because that's also how I understood it. Unfortunately, I had to sort of do a lot of this filtering myself because I learned from a lot of really good restorers. They were way beyond where I was trying to get to. So they took a lot of things for granted, just as I noticed that I started doing lately, taking things for granted, sort of glancing over things where people may want to understand what the hell I'm doing. And it's important to understand what you're doing in this, because the consequences of not understanding, doing something stupid, can be yourself getting zapped. We really don't want that. We don't like that. We're anti-zapping, okay? So once we can understand and sort of identify the different sections of this, we can take this one step further when we come to doing the actual restoration. And that is, I can hide all this stuff and I can actually do something else, because what I do want to do is I want to start on the power supply. And to restore it, to work on it, I can simplify my life if I can sort of hide everything temporarily. And the way to do that is like this. I can actually literally isolate only the power supply from the entire schematic by hiding the rest. Now, most of the time I don't do this unless I'm trying to understand something or I'm trying to explain something, but this is to give you an idea of how simple the procedure can be if you can isolate the confusion, okay? This is just the power supply. You've got your mains coming in here, and you've got your B plus coming out there, and you've got your 6.3 volt heaters over here. Now, there is something else here that shouldn't be here. You see, this radio has this thing over here, which we don't have. This is a turntable. So this switching was actually operating for a turntable as well. And again, because this radio doesn't have it, this particular model doesn't have it, I can actually go a step further and hide it away. There we go. The other thing is this section over here, it's just the heater windings. This is the winding on the transformer. That winding over there, see that? That there. It provides 6.3 volts AC. It's powering the two dial lamps. It's powering the tube heaters. These are the tube heaters over here. There's a filtering somewhere along the line to remove noise. There is actually a special filtering that happens with the ECC85 as it goes into that front end box. So this is the heater supply, and if you really want to, because that's just wires coming out, you can check for continuity. If you really want to, you can actually hide that away. And this is what we need to look at to restore the power supply section. Not that bad, is it? One transformer, a bunch of switches, a fuse, one selenium rectifier, which is 4 diodes, 2 capacitors, a resistor, and part of the output transformer. Simple, simple, simple. And it's important that you make it as simple as possible, because then your grasp of the concept becomes more ingrained, more complete, long-lasting, okay? In this, that has really been an introduction to the anatomy of a tube radio. I just wanted to share the thought process that I use to really understand how these things work, and especially I learn from explaining. I actually cement what I understand a lot better when I'm explaining it to somebody else. I've always been like that. So I really enjoy doing this, and I really hope you gain something from it as well. In the next episode, or the next video in this series, I'm actually going to be doing restoration of the power supply section, showing you step by step how I go about that. And we'll take this radio one step at a time to the point where hopefully it'll serve as a really important tool to gain more understanding about this whole procedure. So I do hope you've enjoyed that, and if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon, PayPal. Links are in the description below. Thanks for watching. Bye for now, and most of all, stay safe.